Okay, let's start by understanding what electric charges are. Okay, so first and foremost, let's dive into what an atom is. Okay, so what is an atom? This is something that you're very familiar with. So if you look at an atom that I have drawn here, it is made up of electrons that are on the outer circle, electrons. Okay, and right in the middle is where the nucleus is. And we know that in the nucleus is where the protons and the neutrons are located at. So the nucleus houses the protons and the neutrons. So bear in mind that the protons and neutrons are actually very safe in the nucleus. There is no way for us to remove or add on to the protons and neutrons. So really, what we're looking at that can be removed or added in are the electrons on the outer shell. Okay, so let's take a look at this particular nucleus, or rather this particular atom. So let's say, for example, in this particular atom, it has 2 electrons. Okay, and let's say it has 2 protons and 2 neutrons. Okay, we call this atom an atom that is at a neutral state. So an atom is at neutral state when the number of electrons and the number of protons are the same. So atom is at neutral state when the number of electrons are equal to the number of protons, as the case above. All right. So now what happens when we remove the electrons? Okay. So now let's say, for example, we remove, instead of 2 electrons, let's say the electrons is removed. Now, why is it being removed, or how is it being removed? We'll talk about it later. Okay, so right now you can see that the number of electrons and the number of protons are no longer the same. And you can see that the number of protons is actually more than the number of electrons. Then we say that it is no longer neutral. Right now, what happens is the number of electrons is less than the number of protons. So if there are lesser electrons, it means that the atom is at a positively charged state. Okay, or we say that the atom is positively charged. Okay, so an atom is positively charged when it has more protons than electrons. Now let's take a look at the last example when we add more electrons to this atom. How do we add it? Later we'll come to it. All right, so let's say, for example, the moment you begin to add more electrons, okay, say for example. So for example, instead of 2 electrons, I now add 1 more electron to it, to this atom. So this atom now has 3 electrons as compared to 2 protons. So what happens is I have 3 electrons, but only 2 protons. So the number of electrons are greater than the number of protons. So we say that the atom is negatively charged. So summary is that an atom is neutral when the number of electrons is equal to the number of protons. Okay, it is positively charged when the number of protons is greater than the number of electrons. And the third example is shown here, is when the atom is negatively charged when the number of electrons is greater than the number of protons. So these are the 3 states that you need to know of: neutral, positively charged, and negatively charged. Okay, now let's talk about the behavior of charges, either positive charges or negative charges. So first and foremost, what you need to know is, number 1, like charges will repel. Meaning to say that when you place a positive charge and a positive charge near to each other, they will experience a repulsive force, and the force pushes them away. Okay, and this is the same when you place a negative and a negative near to each other, likewise, a push force is applied and they push both charges away from one another. Now, a second scenario is when you have unlike charges coming together. So unlike charges will attract. So when you place a plus close to a minus, okay, you would expect the behavior of the plus and minus is such that there is a attraction force towards one another. Now, this is what we call the law of charges. So the law of charges states that like charges repel and unlike charges attract. Okay, now let's move on to talk about how do we measure charges. So in physics, we are always talking about quantifying phenomena that we are able to put a unit to it, we're able to quantify it. And so how do we quantify, how do we measure charges? Okay, so the first and foremost, you need to know that number one, the SI unit, the unit that we use to measure charge is what we call coulomb. So SI unit to quantify or measure charge is coulomb. Okay, you can write the short form of the SI unit by a capital C. Now, the symbol of charge is represented by the alphabet Q. Okay, so don't be confused when you see SI unit and symbol. Now, symbols is what you use in formulas. So it is very much like your distance equals to speed times time. You use D as T to represent the symbol. However, the SI unit is how you measure the charge. Example, for distance, you measure it in terms of kilometers or meters. So for charges, you measure the number of charges using coulomb. Okay, now let's understand coulomb a little bit better. Okay, now let's understand coulomb even better. Now to do so, let's recap. Let's go back to the first slide and we talk about electrons. Okay, we talk about when we want to make an atom positively charged or when we want to make an atom negatively charged, we are always talking about either adding or removing electrons. So how much charge does an electron carry will determine the charge of the atom. Okay, so let's take a look. How much charge does one electron carry? Okay, so one electron actually carries this amount of charge. 1.6 times 10 to the power minus 19 coulomb. So one single electron is carrying this amount of charge. However, we know that there are millions of electrons, just like there are millions of atoms. Okay, so therefore, counting a single electron does not make sense. So therefore, what we do is we will actually look at what does 1 coulomb represent. So therefore, 1 electron carries 1.6 times 10 to the power of minus 19 coulomb. So therefore, 1 coulomb is actually how many electrons? So 1 coulomb is actually 6.25 times 10 to the power of 18 electrons. So now this is a much more sensible number. So we don't look at electrons. We don't just look at one single electrons, but we look at a basket of electrons. Okay, and we say that this basket of electrons, so assuming this is the basket, and you put in exactly 6.25 times 10 to the power of 18 electrons in this basket. And we say that this whole basket is equivalent to 1 coulomb. So whenever we talk about 1 coulomb, it is always this large amount of electrons. So let's summarize the second part. So first and foremost, how do we measure charges? The SI unit is coulomb. The symbol is Q, which we use in formula. Okay, so how do we understand what does 1 coulomb represent? So 1 coulomb represents a basket of electrons, okay, which is the exact amount is 6.25 times 10 to the power of 18 electrons. If this particular atom, okay, has 16 coulomb of charge, it will tell me that this particular atom carries 16 times 6.25 times 10 to the power of 18 electrons. Okay, and that's what 16 Coulomb means. Okay, now let's move on to the next part. Now, how are electrons added or taken away from atoms? Now, at the very beginning, remember we talked about how you can cause an atom that is originally neutral to become positive or negative, either by adding or taking away electrons. Now, the question is, how? What are the processes that allow us to take away and to add in electrons? Is it that easy? So therefore, there are a few categories to look at. Okay, the first category is insulators. Now, insulators, as we know, are things like rubber, plastic, okay? So in insulators, the electrons are not so mobile, okay? The other category are conductors. Example of conductors would be your metal. Now in metals or in conductors, electrons are free-flowing, and therefore the way we add or take away atoms in insulators and conductors are different, okay, which we will talk more in a while. So how can we remove or add electrons in insulators? So for insulators, because so in insulators, the electrons are not so mobile. So you need to force them out of their home. So therefore, in insulators, it is only by friction that you can take away or add electrons. Now, one form to introduce friction would be rubbing two insulators together. That will force electrons to be transferred from one material to the next material, but both are insulators. Now, how about conductors? Now, conductors, we know that the electrons flow freely, and therefore, you don't need to use friction to force them out of the atom. What you do is we will use a method called induction, which we will talk about later, okay? Now, there is one more subcategory to look at, and that is what happens if you have one insulator and one conductor. How can you charge it? Now, in this case, we will use the third method, which is direct contact, which is simply touching these two materials together. Electrons will be transferred easily. Okay, so in summary, how do we add or take away atoms so that we form positively charged atoms and negatively charged atoms? So the methods, there are three methods, and they depend on the material that we're talking about.